So good morning, everyone. I will leave the chat on. I'm a little winded, so don't get concerned about that. But I am probably going to be a little slow on my feet today. So I apologize in advance. I will be trying to give you the best virtual lesson that I can. I'm sure it has gotten around to you guys at this point that I did test positive this morning for COVID-19. So I will be out for probably a week. And that doesn't mean that everyone shouldn't still pay attention to the very ironic now post that I put at the front of the room about how to maintain health in schools. You know, that whole piece of paper where I'm like, wash your hands for 20 seconds and socially distance, all that stuff is still true. It just so happens that I was, I guess, like already kind of sick when that went through. So long story short, I woke up this morning. I was not feeling good. I didn't feel great yesterday. I woke up this morning and felt dramatically worse and thought, okay, before I go into school and risk endangering my coworkers or my students or, your families, I should do a test. And I'm fortunate to have some tests at home. And it's just like the one that I showed you how to do on TikTok, except that instead of coming up negative, this one came up very, very positive. So I'm infected. Some people have asked me how I'm feeling and how I'm doing and all of that. And I'm okay right now. I feel like maybe I have like a pretty severe cold. I'm achy. I'm impressed by the amount of mucus that can come out of my head. I didn't really ever think that would be humanly possible. I'm a little winded, a little short of breath, tired, and can't really smell or taste anything right now. So, whatever. It is what it is. But in the meantime, we have science to do. So looking, the kind of rules of engagement here are going to be this. I'm going to ask everybody to just keep your mics off unless I call on you. If there's a point where I say, I need someone to unmute and you are sitting there with your hand raised, I may call on you and be like, hey, do you have a question or do you have an answer to whatever we're talking about? And go from there. So let's start out where we left off yesterday. And I need to figure out exactly where we left off yesterday. I also should present my screen if I want you to see it. Let's see. There we go. Okay, is everybody able to see like the whole of my screen now? Just answer in the chat like with a Y or an N. Y for yes, N for no. Nick? Nick, do you have your hand up? Or was that an accident? I don't know.
Her mic broke.
Oh, okay. What else? So, anywho, let's check this out. So yesterday, we weren't quite as good here as I'd like, and it was really like these three. I went ahead and went back and gave everybody some extra points for this one because, like at first I said metal. Sorry. And then I switched it over to ceramic, which is also a good conductor, but it occurred to me both of those things are what we make coffee cups out of, so people kept picking it, even though wood is the one that is actually the best insulator. So, whatever. So you got credit there, but we do need to go back and kind of revisit that. A lot of people answered tundra here, and I just want to stress again, tundra does not have trees. Like the word itself actually means treeless. Calculating kinetic energy is definitely something we need to review. And convection currents. Just like say the word to yourself again and again and again, because everything we talk about in weather goes back to convection currents. Earth runs on convection currents. All right. So we, as far as I know, we made it through the difference in weather and climate. Let's see, Nick, if you would unmute and tell me if that is true, that would be great.
He doesn't have his headphones in right now, so he can't hear you.
Well, I don't think I even have any extra headphones there. And furthermore, you probably wouldn't want to use anything that I've touched. All right. Nick, will you go next door and ask Miss Davis, or will someone ask Nick to go next door and ask Miss Davis or Mr. Gilmore if headphones can be borrowed? So, Riley, you're reliable. We got through the discussion on weather versus climate, correct?
Yeah.
Okay. So I have this printed off, and I will make copies for you.
We going for headsets.
I might change the kid here because he reminds me too much of that kid on page 264. But, when we're talking about climate as being what you expect in the average of weather conditions over a particular region, you guys have covered averages in math, no? Yes?
Yes.
Okay. So we know that basically, to make a long story short, we're taking a data set of numbers, adding all of those numbers together, and then dividing those numbers by the number of numbers, which, makes more sense on paper than it does when somebody's saying it out loud. But, same thing goes with weather patterns. We can look and say sunny day, sunny day, sunny day, sunny day, and like figure out how many days of the past 30 years were sunny, how many days were cloudy. And we update our climate data every 30 years. Basically, it's about to change and become less time than that, thanks to some of the man-made climate issues. All right. So having that down, in my journal for this class, I have evaporation, condensation, and humidity down as a journal page, right? Did we get there? You can answer in the, oh wait, no, I don't have let everyone send messages on. Sorry, my last class was spamming the chat really badly, so I cut them off. So we do have our journal page that starts with evaporation, condensation, and humidity. Okay. All right, so when we talk about humidity, we are talking about the amount of water vapor in the air. If you can see it, is it water vapor? Like fog? Somebody unmute and say yes or no.
No, it is not water vapor.
Right. Water vapor is a gas. It is invisible. So fog, not water vapor. Clouds, not water vapor. They're made out of either liquid droplets or ice. So we left off on this discussion yesterday, I believe, and I want us to pick up here today. So we know that warm air can hold more water vapor than cold air because warm air is less dense and the particles of air are spread out, the molecules are spread out. So there is more room for water vapor molecules to move in. In cold air, it is denser. There is less room between the molecules. There is less room for water vapor to move in. So cold air holds less or can hold less. Warm air can hold more. Does that necessarily mean And let's see, who can I call on from here? Marianne. Does that necessarily mean that warm air is going to be holding more than cold air in a given place?
Yeah.
No, actually, because think about it. We have places like, the Sahara Desert, very warm. The air above it is very warm. Is it holding a lot of water vapor?
No.
No, because there's no, well, no, that's a spoiler. So remember that evaporation and humidity are very closely linked when you're thinking about this. So I want to know what kinds of areas around the world you think have the most humid air, and also, you know what, I'm gonna up this ante a little bit if I remember how to use a computer. Sorry, I put on makeup so I didn't look as horrible as I felt, but now I just like look fantastic and feel terrible. I don't really look that fantastic. So what kinds of areas have the most humid air and the most dry air, which we actually call arid, but it's hard to say arid air. It just sounds weird. Okay. So, like I said, we know warm air can hold more moisture, but deserts are often, they're warm, but they have very low humidity. Places like, even around here, we can get a lot of snow, go outside, and it's cold, but it feels humid. We know that we have a high humidity level. So, other than temperature, what are the things that you think affect humidity in areas around the world? I'm going to give you guys 3 minutes to discuss this with your chosen partner. And I want you to discuss this and really think about like the geography and things that we've talked about. You do have a computer in front of you, so you could do a little bit of research if you're just really stuck. Think about biomes and what we've talked about with like the ground and holding water and biomes, things like that. And like just 3 minutes. Let me hold on. I've got, I need to set the timer. Okay. You have 3 minutes starting now. No, sorry. I peed Trebek. That was a tough loss. All right. So let's hear some of your answers. I'm going to try to get to where I can actually see you again. All right. If you have an answer, please have your hands raised so that I can see that there. Okay. Gavin?
Stuff like the water cycle and like trees and animals, like things that can carry water and like their capacity that they hold water, maybe.
Okay, so you have so many things there that are like directly relate to the answers I'm looking for. But I would like to hear it more in terms of like how like where in the world are you going to see things like that? Like where in the world are you going to see geographic features or, you know, even organisms like you brought up that like hold water in place and make things more humid?
Grasslands specifically.
Okay. So grass, we know, holds quite a bit of water in place, and a lot of evaporation can happen if we have like soggy, wet grasslands, and that could lead to more humid air. Now, we know that that's not the most, it's not the biome that gets the most precipitation by any means, but it certainly gets enough that we could expect some humidity there.
Yeah.
I would say, especially in tropical grasslands, it's probably sometimes one of our drier areas and sometimes one of our more humid areas just based on the season. Okay, other answers. Let's see, Eli.
So what I said was the rainforest because they are rather warm and they're not called rainforests for nothing because, yes, they're wet.
Yes.
And so they are, in turn, very humid and hot places.
Okay. That's a great answer. So, you know, rainforests by definition are forests that get a lot of rain. And if we're thinking about them being tropical, we know the temperature is going to be pretty warm. If the temperature is pretty warm, we can expect there's going to be a lot of
Rain.
that's
Oh.
that's the
I forgot
opposite
if it's condensation. No, evaporation.
evaporation.
Precipitation. Oh, yeah, do that.
Precipitation, rain.
Stop at evaporation. You've got it there. The word vapor is in the word. Yes, evaporation. Okay, Nick. I see your hand up.
My mic not be great, but I'm gonna try.
Oh, it's
Okay. Oh, I just ripped it. Okay, so what I would probably most likely think would be either the rainforest or deciduous forest. Well,
Okay.
Eli already explained rainforest, but I would say deciduous around this area because it can hold humidity through cold air, so there's really no super big limit on it.
Yeah,
And it just keeps going warmer.
and you know we get a lot of a pretty good amount of rain around here. Sorry, I'm out of tissues and I had to go back to Christmas napkins. It's not fun. Sorry. Just forgive me. I have COVID. So we get a lot of humidity. And again, if there's a lot of water in the ground, that means, and we have a lot of streams and ponds and areas like that, there's a lot of water to do what? Not rain, but
Evaporate.
great. So what would be some of the drier areas?
Deserts, tundras, stuff like that.
And you know, tundra and taiga are a little bit interesting because so much of the water just stays frozen and then kind of thaws back out and evaporates. But yeah, you're right. They absolutely are a little bit more dry. Deserts definitely. There's one like colossal issue that I'm noticing with all of my classes. Here's one area that we should really be thinking about a lot of evaporation happening. It covers like 75% of the Earth's surface, and like no one's bringing it up.
Oceans,
Oceans.
big oceans.
Oh,
So, we should guess that if we just have a large body of water, there's going to be a lot of water evaporating from it. So most of our evaporation is going to come from oceans, and we'll have a lot of humidity along coasts. Even if it is very cold, we'll see a lot of evaporation from oceans. Okay, good. So when we measure humidity, yeah, I know I'm presenting to everyone. Oh my gosh, it's not like I don't do this like every third day. We actually, when we talk about humidity, we talk about it in terms of relative humidity. And I want to clear up that like the word relative can have multiple meanings. It could mean like, oh, my cousin is my relative, but that's not what it means here. If we're talking about relative as in like, here it states, and don't worry about writing anything in your journal. I will put up the journal page later and you can just copy it as you will. Relative humidity is a percentage of how much water vapor the air is holding compared to how much it can hold at a certain temperature. So when we're talking about relative, we're saying like, oh, it's holding this amount of water relative to what it can actually hold. So like in that sense, relative is kind of a synonym for what? Like maybe compared to, that's what we're thinking of with relative humidity. So this is where it becomes important to remember the relationship between warm air and humidity. Warm air holds more or less, or can hold more or less water. Anyone?
What was the question?
Warm air does it hold more, or does it have the potential to hold more or less water than cold air?
more.
More.
Mm-hmm.
Depends more.
Yeah. So, yeah. Okay. And cold air can hold less. So when we talk about relative humidity, it's important to remember that. When we're talking about it as a percentage, what it means is like, just as an example, if an area of air could hold 100 grams of water at 70 degrees Fahrenheit, water vapor at 70 degrees Fahrenheit, and it only has 42 grams of water vapor, what's the relative humidity? If it's a percent, 42 out of 100 is
42%.
42%. So if we have that same amount of water and the temperature drops and like the molecules of air become more dense and there's less room for water vapor in there, that same amount of water vapor counts for a lot more. So as the temperature drops, relative humidity goes up if the same amount of water is present. If we have a temperature rising and the molecules could like then hold, or they're spreading apart and the air could hold more water, relative humidity goes down because now there's more room for it. It's an inverse relationship. And this graph shows that. So you want to remember, as temperature rises, relative humidity goes down. And we see that here. Temperature rising, relative humidity drops. Temperature drops, relative humidity goes up. And it's all just because of like how densely packed those molecules are. So this is how we actually talk about it. We talk about it as a percentage. I'm going to give you guys a few minutes here. Let's see, we get out at 9:33. Okay, so we have a couple of problems here for you to calculate the percentage and figure out the relative humidity of an area. So if the relative humidity of an area is reported to be 60%, but it could hold 240 grams of water vapor, how much water vapor is actually in the air? So that answer is going to be expressed in grams. And if an area has 35 grams of water vapor in the air, and it could hold 220 grams of water, what is the relative humidity? I'll give you guys about 5 minutes I'm going to turn my camera off because I feel I feel like a lot of hacking is about to happen and nobody needs to see that. So I would like you guys to take about 5 minutes. You can work with your partners. That's totally fine. Don't be too loud. If you're too loud, you have an adult in there who has full permission to tell you to hush. But I'm going to give you about 5 minutes and let you solve these problems. Okay. So we should be doing okay. I see raised hands. So for our first one, I saw a lot of people putting in 144, and that is correct, but you should put in 144 what?
Grams.
Grams.
Grams,
Was
absolutely.
it gallons or grams?
Grams.
That's awkward.
Yeah, so many things aren't they? Um, all right. So then on our second one, it's a little bit different setup. If we know that an area can hold this, we're looking to see what percentage 35 grams is of 220 grams. So what is our relative humidity here? 35 is what percentage of 220? And you can just type your answer straight into the chat. Sorry, that's probably going to be the easiest. Oh, that's a good look. Okay, so Nick, how did you get 6%?
I think I screwed this up, but I tried to find the percentage of 35 to 220. So, wait, that doesn't make sense at all, does it? 12, 10. But the only thing I got was I couldn't do 6 or 7%, so I just said around 6.
Okay.
That's like 6 times 35 equals like 210.
Okay. 15.19% is what I got, Marianne. So the way I would have, there are a lot of ways you could have done this.
I think I screwed up.
And yeah, definitely. Never worry about like, or never hesitate to do just like cross multiplication. That is something that you absolutely can do, and it's like an easy way to do it. So, one of the things that you could do is take the number 35, multiply it by 100, and then divide by 220. And are those my numbers? I think those are my numbers. And that'll give you the percentage. There are so many different ways to find percentages. You can let me look up my numbers again. Sorry, I forgot what they are. Yeah, if you divide 35 by 220, and then just multiply by 100, meaning you move your decimal point to 2 to the right, that will also give you the correct answer. So there are a lot of like easy tricks for finding percentages. I wish I was there to just like show you on the board. It's a lot easier. Good job, Marianne. Good job, Gavin. So your homework for the evening. I don't know what my child is doing. It's he's downstairs and he sounds hilarious. Your homework for this evening is just to complete page 263. So you need to read page 262 to probably be able to do that. It tells us about a psychrometer and how it works. You have a wet bulb and dry bulb thermometer, and basically you take this thing and just go out and sling it like it's a noisemaker. And it does make kind of a strange noise, but it's not anything super exciting. And if the air is very dry, this wet bulb will also dry out, and evaporation requires like a use of heat. So it will cool that bulb off. And you'll see a noticeable difference in the two. If the relative humidity is high, the bulb won't dry out very much, so the temperature won't drop. And that's how it literally means measuring cold. So the psychrometer is the tool that we use to do that. And this is going to tell you a lot of the same stuff that I told you about relative humidity. As far as page 63 goes, so I put directions on how to do this. These questions at the bottom all need to be answered, even the ones down here. If you're like, I need extra help with, just think of something, even if it's not related to this unit, be like, I need extra help remembering all the formulas from the beginning of the year. That would be fine. So I put the directions in on exactly what you need to do here. And I did the first one. So the first thing you do is find your dry bulb reading this is all psychrometer data. So it tells us here that the dry bulb is 18 degrees Celsius. Okay, so I found that. And the wet bulb is 14 degrees Celsius. So I have to find the difference between those two. Difference tells me that I'm going to be doing what mathematical operation? Somebody unmute and tell me.
Subtraction.
Yes. So doing subtraction, I'm going to go through and find the difference. The difference between 18 and 14 is what?
4.
Yes. So I find the difference here paired with my dry bulb reading and find where they intersect on the graph. And I would have 64% relative humidity. So again, these notes are up there for you. I will give you the rest of class, which is not that long, but a little less than 10 minutes. That's probably enough to get it done, to get this done.
9 minutes.
Does anyone have any? Yes. Does anyone have any questions before I depart and go like, lay around and hack? Emmeline, I see a raised hand.
Is there any way that I can come pick up my science books?
Yeah, as long as you have someone to drive you, it shouldn't be a problem.
Okay.
I can, Marianne, do you care to look for Emma Lynn's science book and take it up to the front office?
No, I can do that.
And Emmeline, do you need your journal as well?
Yes, that would be good.
Okay, how are you feeling? You don't, no offense, you don't sound
I'm pretty sure that I do have COVID because my parents do, so I just got tested yesterday.
Turn your camera on and we can high five each other because we are in the Fountain Pen COVID Club.
I hope you feel better, Emmeline.
Yeah, I hope you do too. I got a replacement and have some beautiful ink in it right now. So I think, Emmeline, I gave you a sample of the Henry David Thoreau ink, and it's absolutely gorgeous. So have fun. But you guys go get things done. Colt, do you have a question?
I have 2 questions.
Okay.
One, when you're calculating water vapor in the air, do you always use grams?
Either either grams or micrograms, but yeah, it's usually grams, and it'll be like per cubic whatever, per cubic yard. It just depends on like who's doing what.
My second question is, do people actually live in the tundra and taiga biome?
Oh yeah. Yeah. The taiga is my dream biome to live in, and yeah, a lot of people absolutely.
All right, I hope you feel better.
All right, thanks. All of you guys take care. If you have any questions, please email me. I'm gonna be around. So talk to you soon. Bye.
Bye.